Alrighty, so in here we're going to graph the quadratic function negative 2x squared plus 4x plus 6. This function is written in standard form in the form of ax squared plus bx plus c. And something we learned about the standard form is that it easily gives you the y-intercept. So that's actually something we can already start listing. The y-intercept in the standard form is just a constant value of the standard form of the quadratic function. That means it's the number without the variable. So the y-intercept will be the point, because at the y-intercept x is 0. So the point 0, 6 is the y-intercept. Now what we're going to do is we're going to find the vertex. Whenever we find the vertex from the standard form, we're going to use this formula, x equals negative b over 2a. And that's going to give us the x value of the vertex. So we're going to list the coefficient of the squared term, which is negative 2. That's our a value. The b value is the coefficient of the linear term, which is 4. And c is just a constant term, which is the one without the variable, 6. So let's find the x value of the vertex. So the x value of the vertex will be negative 4 all over 2 times negative 2. So negative 4 over negative 4 is just 1. So the x value of the vertex is positive 1. Now to find the y value of the vertex, we're going to plug in this value of x into our function. Negative 2 times 1 squared plus 4 times 1 plus 6. So that is negative 2 in there, because 1 squared is just 1. Then we're adding 4 and then 6. So the y value of the vertex, it is 6 and 4 give you 8. And then, 6 and 4 give you 10. And minus 2, that is 8. I was just skipping a step, but y equals 8. So the vertex is going to be the coordinate point 1, 8. That is my vertex. So 1, 8 right there. That's my vertex. The axis of symmetry is a line of symmetry that makes the parabola symmetrical, because parabolas have symmetry. So the axis of symmetry is just going to be the x value of the vertex, because that's going to create a line of symmetry for the parabola. So the line x equals 1 will be the line of symmetry. And I'm going to graph that in green. So that is my line of symmetry, also known as the axis of symmetry of the parabola. So x equals 1 is the axis of symmetry. There we go. And now we want to know if we're going to get a maximum or minimum value. So the maximum or minimum value, that is either the maximum or minimum y value of the parabola. In this case, we notice that the value of a is negative. So we have negative 2. That means our parabola is going to open down. So we're going to get a maximum value in our parabola. So we're going to get a max value. And the max value is going to be the y value of the vertex. That is because the vertex is either the highest or the lowest point of the parabola. So the max value is going to be at y equals 8. And now we're going to graph our y-intercept. So the y-intercept is a point 0, 6. The reason we're graphing the y-intercept is because when we graph the y-intercept, that's going to help us find another point that's symmetrical to that point in order to let us graph our parabola. So the y-intercept is 1 unit away from the axis of symmetry. So what I want to do is I want to get another free point by finding a point that is a reflection of the y-intercept. So since the y-intercept is 1 unit away from the axis of symmetry, the other point that's going to be a reflection of the y-intercept is also going to be 1 unit away from the axis of symmetry. So that point will be right here. Since this point is 1 horizontal unit away from the axis of symmetry, just as the y-intercept is. So that is our free point. And now we can graph our parabola. If you use the box and diamond method, you can figure out that the x-intercepts are at +3 and at -1. But you actually, this problem doesn't require you to do that, but you can do that if you want to by using the box and diamond method. But now we're just ready to graph our parabola. So let's draw a nice smooth U-shaped graph like that. And there we go. That's our parabola.